Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today we are going to start chapter number 9 of your book, Sources and Effects of Heat Energy. In this chapter, we are going to study about heat energy. We'll discuss what are the sources of heat energy and what can be its effects on different objects. We'll discuss effects of heat energy on solids, liquids, and gases. Okay, let's start with the definition. What is heat? How can we define heat? Heat is a form of energy that is transferred from a hot body to a cold body. You are aware of different forms of energy around you, like thermal energy, solar energy, electrical energy, nuclear energy. So heat is also a form of energy which always flows from hot body to a cold body. For example, let's suppose that you have a hot cup of tea and you place it into a room. After some time, if you touch the cup of tea or you try to drink it, you feel that tea is cold. What has happened? Tea has basically transferred its heat energy to the room. It has given off its heat to the room. Heat is transferred from tea, which is at high temperature, to the room, which is at lower temperature. So that's how heat transfers, and this is a form of energy which flows from hot body to a cold body. Or you can also define it the form of energy that is transferred between two bodies which are in thermal contact. Okay, what is this thermal contact? Thermal contact means the two bodies should be allowed to exchange heat between them. They should not be sealed from one another. Heat should be flowing between those two bodies. For example, let's suppose that you have placed the same tea into a thermos. Now, the tea is being sealed. It is placed into a thermos. Thermal will not allow the cup of tea to exchange its heat with the room. So these two bodies are not in thermal contact. And for heat to flow, thermal contact is required. Both the bodies should be allowed to exchange their heat. Or heat can also be defined as heat is the energy in transit. Heat is also called energy in transit because it is associated with flow or transfer of energy. It is a scalar quantity and it is a derived quantity. It is denoted with Q. Its unit is joule. Joule is the system international unit of heat. Calorie is the another unit of heat. Okay. Modes through which heat can be transferred from one object to another object. There are three processes through which heat can be transferred from one body to another body. Number one is conduction, number two convection, and radiation. Conduction takes place in solids. Convection occurs in liquids, in gases, or you can say it occurs in fluids. And radiation takes place in vacuum, where there is no medium, there are no particles. Heat will be transferred in by the process of radiation. Importance of heat energy. Heat energy is very, very important to keep our body warm. So we need a specific body temperature to stay alive, and for that we need heat energy. It helps the fruits and crops to ripen. It maintains specific earth temperature which we need to stay alive. If there is no heat energy, there are no sources of heat around our earth, we will not be able to live here because the temperature will drop to the minimum level and will not be able to stay alive. And it is also used for preparation of different industrial products. Sources of heat. Sun is the biggest source of heat and it is the biggest natural source of heat. There are other sources as well, but sun is the biggest natural source. The other sources are food. We eat food. Food goes into our body. It is broken down by the process of metabolism and heat energy is released. We use that heat energy to perform different activities of our daily life. And then we also get heat by burning of fuel, and during power production heat is also released, and electricity is also a source of heat energy. Like you're aware of different electrical appliances which are converting electrical energy into heat energy for you. For example, electrical heater, electrical stove, your hair dryer, your hair straightener, all these are the electrical appliances which are converting electrical energy to heat energy. So they are also, electricity is also a source of heat. Next is effects of heat energy. What happens if you try to heat up any object? There are two changes or two effects that you're going to observe as a result of heating or cooling any object. First is thermal expansion. What is thermal expansion? The expansion of the material object on heating is called thermal expansion. What happens to an object when you heat it? Solids, let's talk about solids first. Solids are made up of atoms and molecules. These atoms and molecules are very tightly packed. If you look at the solid structure, you will come to know that there are very small spaces between particles of solid. Between the atoms and molecules of solids, there are very small spaces. So they are very tightly packed. that their particles, their atoms can hardly vibrate about their mean position. They're not able to leave their positions, but they can hardly vibrate about their mean positions. So when you heat up a solid, what happens that the atoms and molecules absorb that heat and they use that heat energy to increase their kinetic energy. As a result, vibratory motion or the vibration of the atoms increases. Their amplitude of vibration increases. They try to push the neighboring atoms and molecules away from them. As a result, interparticle or intermolecular distances increases and solids are expanded. That's how solids expand. On the other hand, what if you cool down a solid? The process on cooling is called contraction. And how can we define thermal contraction? The contraction of material objects on cooling is called thermal contraction. Now, what happens if you cool down any solid object? Again, solid particles are closely packed. If you cool them down, you're basically taking off their energy. Their kinetic energy as a result decreases. Their vibrations become slow and the interparticle distances decreases. Their amplitude of vibration decreases. As a result, the particle distance decreases and the size of the solid decreases and the solid is contracted. So that's how thermal expansion and thermal contraction happens in solids. Okay, next is an activity. It is activity number 9.1 in your book, and we are going to prove in this activity that solids expand on heating and contract on cooling. To perform this activity, material or apparatus that you need is metal bobbin ring apparatus, in which you will have metallic sphere, ring, chain, a stand, a burner, or a spirit lamp. Okay, what is the procedure? Take a metallic sphere which can pass easily through a ring as shown in the figure, and then remove the sphere out of the ring with the help of the chain attached to it. Heat the sphere to a high temperature and put it on the ring in order to pass it through the ring as shown in figure. Does it passes through the ring after heating? Okay, what you have to do that you need to take a ring and a sphere and make sure that the sphere passes through the ring easily. Now, take the sphere and heat it by the help of the spirit lamp and try to pass it again through the ring. What will you observe? Then let the sphere cool down and again try to pass it through the ring. What will you observe now? You need to take two observations, and your observations will be, when you heated the sphere, it does not pass through the ring. Why? Because it has expanded. You will feel that the sphere has expanded on heating and it is not passing through the ring. When it is allowed to cool down, the sphere passes through the ring easily. What is the reason? Reason is that on heating, kinetic energy of molecule increases. Molecules absorb energy and they use this energy to increase their kinetic energy, which increases amplitude of vibration, and molecules move far apart from each other, so sphere expands and it is not passing through the ring. On the other hand, on cooling, the reverse happens. Kinetic energy of the molecules decreases. As a result, their amplitude of vibration decreases and they contract. Solid contracts, so it easily passes again through the ring. So through this activity, we have proved that the conclusion is solids expand on heating and contract on cooling. Then expansion depends on nature of the material. Different substances expand differently depending upon their nature. For example, if you take solids, all the solids will not expand, and if you give them same amount of heat, all the solids will not expand at the same rate. Different solids will expand at different rates. Some will expand more with the same amount of energy and some will expand less with the same amount of energy. It all depends upon nature of the solids. For example, if you take 1 meter brass rod and 1 meter iron rod and you heat both of them to 100 degrees rise in temperature, you will observe that the brass rod has increased 1 millimeter and the iron rod has increased only 0.6 millimeter in length. So you see the difference between increase in length, that brass has expanded more and iron has expanded less. This is only because brass and iron are two different metals. They have different natures. That's why they are expanding at different rate. Okay, by using this concept, we have made a device that is called bimetallic strip. How bimetallic strips are made? Bimetallic strips are made by joining two metals of different expansion, such as brass and iron. You take two different metal strips, you join them together, and what you get a bimetallic strip. Where do we use these bimetallic strips? We use them in thermostats to control different temperature of different appliances. Like you have it inside your electric iron, you have it in your air conditioner, you do have it in your fire alarms. There are different appliances in which bimetallic strips are present. Here we have another activity. This is activity number 9.2 from your book, in which we are going to prove that different metals expand or contract at different rates. As we have already discussed, that different metals expand at different rates depending upon their nature. What you need to do, you need to take a bimetallic strip and heat it up. What will you see? You need to observe that what happens to bimetallic strip when it is heated. Now allow it to cool at room temperature, and then again take an observation that what happens when it is allowed to cool at the room temperature. You will observe that on heating, bimetallic strip bends, and on cooling, bimetallic strip straighten again. When you heat down bimetallic strip, what happens? Bimetallic strip has two metals. One is iron, which has less expansion, and other is brass, which has more thermal expansion. So when these two metals are joined together and when you heat it up, brass try to expand more, where iron does not expand at the same rate at which the brass is expanding. As a result, the bimetallic strip turns. It is bent. And when you allow bimetallic strip to cool down, what happens? Brass again contracts at the same rate to which it has expanded, and iron also contracts to the same rate it has expanded. As a result, bimetallic strip straightens again. So we have concluded that as this has happened because different metals have their own expansion depending upon their nature. So we have concluded that different metals expand and contract at different rates. That's all for today's lecture. Today we have discussed about heat. We have learned definition of heat. Then we have discussed sources and effects of heat energy. And then we have studied effects of heat energy on solids. We have proved it by the help of two different activities. First, we have proved that solids expand on heating and contract on cooling. Then we have discussed different rates of expansion of solids. It depends on their nature. So this is all about today's lecture. Go through this lecture, listen to it carefully, and make your assignment accordingly.